My name is Jalendra Rizal, entomologist working in this area. So today I'm going to talk a little bit about Navel Orangeworm very briefly because I believe we'll cover that in later part of the presentation. But most of my time I'll focus on this new Carpophilus beetle and what we have seen so far, what we have learned so far, and what we know, right? It's a new pest, as you know, and so we're learning as we go. Let's talk about Navel Orangeworm a little bit because we thought that 2023 was the year, that worst year, and we don't see any Navel Orangeworm after that, or at least to that level. So Navel Orangeworm, this is just a kind of symbolic picture. I was just thinking what picture I should put, and I just put that there. But one thing I want to mention is that this is one of our insecticide trial sample. And when I do the trial, I need to find the places where there is a lot of activity. And so that maybe I'm biased a little bit, but if you looked at those bags, each bag has Navel Orangeworm infested nuts. And those are crackouts from 150 nuts. So out of 150, that many there you can see has Navel Orangeworm infestation, right? So some cases we're finding 30, 40 nuts out of 150 has Navel Orangeworm. But again, it's not across that, of course, but it definitely shows the pressure this year also that we're seeing Navel Orangeworm in almonds. A little bit about the seasonal phenology of this insect in 2024. What you are seeing in this slide here is that kind of throughout the season in 2024, the very early, as you see in here, so the spring flight, as you see always it's kind of lowest. Probably I need to mention that those purple bars is the one that I usually use as a reference. Those are the egg counts. So that first flight, so this is a kind of the first overwintering flight, the first generation egg laying activity here. And then there is a little bit deep, and after that you can see the second generation. Try to kind of divide that based on that second generation, third, and fourth, right? So you can see if you looked at a couple of things can be noticed here. So one thing is if you looked at the Navel Orangeworm activity throughout the season, there is no pause. Throughout the season you see the egg laying activity happening. And the other thing to notice is that always this first flight is okay, and we're okay until that hull split time also in terms of if you look at the number, and it go to the second flight, second generation wasn't that bad, and then third and fourth, you always get that higher number. But if I compare this from 2023, it shows in here. Again, this is a 2024 and this is 2023. We had kind of more or less similar pattern, but I would say that we had less pressure in 2024 for sure. But still, if you looked at the activity throughout after the hull split time, there is constant activity until last week or so, right? So that shows the period of the Navel Orangeworm activity after the hull split, consistent pressure. And that is the one that is causing issues on nonpareil, but more so on pollinizer. And so we're seeing this kind of scenario pretty much every year. So that's why this year I've heard from several of the growers PCA that I've done everything right, but I still have 4% damage, 5% damage. What went wrong? So I think overall Navel Orangeworm pressure in the valley is pretty high throughout. So in that case, and plus, other factors also in playing into role. I'll talk about a little bit more about that. But if you look at this scenario, so my main point is that if you have that kind of scenario, you need to utilize all the available tools you can utilize from the beginning to the end in order to get the good results. So what are those tools? Nothing new, right? Everything you've heard of it. In fact, some of them are very, very old tools, techniques. 1985, that's where the winter sanitation concept came. That's when they saw that winter, if you do the mummy sanitation, you'll get the good results. And since then, we're practicing to a certain degree. But if you look at overall adoption of the winter sanitation is pretty low. I mean, for the given the standard of the nut crop industry, almonds, maximum we get be about 50% of the orchards in our area that have winter sanitation. So that definitely is causing one of the main factor for navel orangeworm increased pressure is not having this winter sanitation in those. Plus, if you go to timely harvest and other things, I thought that we're better this year in terms of harvesting on time, but wasn't that the case. If you looked at last year versus this year, harvesting time for non-pearl is still, it's very extended period. Maybe that constant heat for 2 weeks or so, 100+ temperature kind of create the environment where there is non-uniformity in hollow split. I don't know the exact reason, but it's still our non-pearl harvest was also very late, where we pretty much intercepted all the third flight on those non-pearl nuts. And we do have mating disruption, which is biological based tools. It is not the silver bullet, as you know. None of these tools are silver bullet. But if you adopt the mating disruption early part of the season, that helps to reduce the population. But I would say that if you want to do it, mating disruption versus the winter sanitation, orchard sanitation, number one is orchard sanitation, because in order for the mating disruption to be effective, you also need to have a pressure to a certain level, right? So if you have, very, very high pressure pretty much throughout the season, even though under the mating disruption, there is still good chance that the mating happens, and you may not get the results as much as you want. So doing winter sanitation is critical factor, and a lot of abundant orchards out there, people are kind of relaxed their pest management practices, especially with winter sanitation, because of the cost and other things. But I think it's still a critical factor to do it. And also, I've heard quite a bit that some of the orchards with the winter sanitation also had some damage, which is, can happen with the neighbor and other things. But think about if you did not have the winter sanitation, right? So that's another thing to think about, because you're not comparing that with the scenario where there was winter sanitation not happening. Plus insecticide. Insecticide would do so much, and we have seen this many times. We apply, 2 times, 3 times insecticide, pretty common now, pretty standard now. But even with that, you cannot control navel orangeworm just by insecticide, and so all the reason. Coverage, the efficacy of insecticide is good, but if your coverage is not good, and most of the orchard, because you're applying the insecticide to the orchard, it needs to reach to the suture where it becomes effective. And there's no way that you can get that 100% to the suture. So there is that, right? So you also need to take all these tools and kind of together, combine those effort and do the IPM for navel orangeworm. So I think that would be something that we definitely need to focus in years going, not only with the orchard sanitation become more important for navel orangeworm, but also Carpophilus beetle. I'll talk about that a little later with some of the example also. Okay, so that's all I have for navel orangeworm management. Again, I think that we'll hear more from Mel. He has quite a good results from throughout the valley, pretty much throughout the state average and things, and we'll learn more about that a little later. Okay, so with that in mind, I'll move on to another topic, the invasive Carpophilus beetle, which is a newer pest, as you know. So we confirmed this beetle, little tiny beetle, as you see the size there, and then in its larva. So we confirmed the presence of these in infesting the orchard in 2023. We also had quite a bit sample damage occurred in 2022 from this pest. And originally we were seeing a couple of counties in the San Joaquin Valley. Now, based on the latest survey by Houston Wilson and the entomology specialist at Kearney, we're working together on this beetle, pretty much all entomologists throughout the valley, because it seems to be a big deal and it's widespread already. So based on this survey, pretty much all the county in San Joaquin Valley have Carpophilus beetle at this point. It's a type of sap beetle. I'll talk a little bit more about the other species present in our area a little later, but we found infested in almonds, pistachio, and also limited number in walnuts. So I'll talk just so is some limited data on that walnut. So in Australia, they also have Carpophilus truncatus. This is a new species. It's a Carpophilus beetle, we call it. So the species name is truncatus, so Carpophilus truncatus. They are dealing with this pest since 2013 knowingly, and they get 2 to 5% average damage every year just by this pest. And some years, some of the orchard, they get up to 30-40% damage also. The other thing about Carpophilus beetle is that both adult as well as larva, adult and larva both can feed on the nut. So they can basically get into the nut meat and cause damage, both of them. Okay, so just a little bit biology side of things, this beetle, right? So this is not, these are several different species within this group called, within the insect family called Nittidiolide. So they are these small ovular bodied insect. Majority of these insects present in many different systems and throughout the United States and other countries, but they are essentially a secondary pest. They infest on the crop overripe, or when there is already compromise or some damage already happened. So it's a secondary pest. So these are multiple species of the Carpophilus genus, which look more or less similar, and there are several species present in California also. These are the species present in California, we know, and get confused easily with the Carpophilus truncatus. It's not that easy to identify Carpophilus truncatus from the other species, because it could be the reason that we have not noticed the damage in the last couple of years, given that we've already seen the widespread damage throughout the valley. But the unique thing about Carpophilus truncatus is this is the only species that we know of had actively attacking on the healthy nut compared to all other these beetles and things that we have seen in other crops. So they are the one that goes lay eggs on the nut right on the tree and then cause direct damage. So that's definitely the different thing about this. And so to our knowledge so far, we know that this is the only species causing it in not focusing on nut crops. Okay, so this is data that I collected last year, harvest data from 2 different orchards in Merced. The Merced orchard was in Livingston, Cressy, sort of that area, and Stanislaus was in West Modesto area. So what you're looking at is the kind of overall damage from the harvest sample in Merced. It's about 12% total damage on the crackouts. The other one was 38% total damage. On there, you can see the distribution. The first orchard had Carpophilus beetle. About 20-25% of that 12% were Carpophilus beetle. And then Nabelungum was higher, close to 60%, and then combined. So that's another thing. Carpophilus beetle and Nabelungum can combinedly infest the same nut. And so that's why we get confused. When you see the symptom, you see the Nabelungum symptom a lot more predominantly, and that's why we have the knowledge about. And so that could be another thing, that misdiagnosis of this insect. On Stanislaus County, it was reversed, so we had a lot more Carpophilus compared to Nabelungum. So it's pretty much, I'd say about 30%, 33%, but it varies by orchard. But as you see here, that they can do a pretty substantial damage. In walnut, so this is the first report that we collected last fall in one walnut orchard. These are the orchard I want to say that they were already harvested. We did not collect those at the time of harvest, but about a week after the harvest, there were leftover nuts on the ground. That's where we collected this sample, and you can see Nabelungum as well as Carpophilus beetle, right? So when you see that Nabelungum, big pink color insect right there, you might not notice that tiny white larva on the side, right? In this orchard, we had it's a small orchard, so small acres. So when we had Hartley, Eureka, and Chandler variety, on the Chandler variety, we did not get any infestation by Carpophilus beetle that year. So this year, we also collected the sample from the same orchard. We're cracking them out, and then my technician yesterday mentioned that we have not seen any damage in Chandler variety yet. So we are still cracking the Eureka and Hartley variety, so I don't have the answer for those. But Chandler seems to be a lot more tolerant compared to what we've seen in almonds and pistachio. Hopefully the walnut may not be as susceptible, and it can be a storage pest though, because they can go into the storage, and if they infest in the storage, that's a different story. Pistachio. So this is a picture from last year. Taken, and you just see basically the larvae and the beetles, they feed on there and then just kind of basically turn these nut meat completely into the powdery form, as you see here. And sometime also when you see on the second photo, you can see there is a kind of frass and hole in there that's indicative of the Carpophilus beetle. That's from last year. This is an orchard that I visited about a month ago. We looked at in Merced County actually, and so it's a relatively big orchard. It's close to 1,000 acres. And when we looked at in the beginning, we had these small pea-sized pea split nuts, as well as the hull slip nut, as well as the nut that is ready to harvest, but it did not have any rupture in it. And so initially we were finding a lot more on those two categories, but the intact nut was not infested with the Carpophilus beetle. But when we took the sample enough, then we'll see the damage on those intact too. So at the hull split, anything in the pistachio orchard can be infested by Carpophilus also. And on that orchard, you can see the number. It's about 4.5% damage just by Carpophilus beetle. So it can be pretty serious pest in pistachio. I'm kind of trying to gauge between the almonds and pistachio, and it's very hard to do it, but I think it's about the same, that level of susceptibility they have. More picture from that orchard, and as you see, already seen the powdery stuff that coming out from there because of that infestation. Now on, I'll talk a little bit more about the symptom that you will see in almonds, because as I said, it's misdiagnosed a lot times. So if I provide some of the picture a lot more, that might be helpful for identifying these infestation in the orchard. Okay, so this is what I've seen in the beginning when you go at the hull split, or just after the hull split, or even after the after the harvest also, you still have the nuts hanging on the tree. If you see those white powder coming out from these cracks, sometimes the cracks just natural cracks, other times there's a hole that the beetle made, and then that's where these powdery stuff is dripping out. For example, this one. You can see in the tip of the almonds of the nut, you can see the hole, and that's where the nut powder is coming out. And so this is a good indicator of the Carpophilus infestation in the orchard. So you can test that right now also, right? When you go in the orchard and look at for damage. Again, the same thing, just kind of trying to somehow they will find that tip is maybe easier to chew, and then the beetle will basically make a hole, lay eggs outside, inside, and cause damage. And that's why we see these holes a lot more on that tip. Sometimes we'll see in the middle part of the suture too, but it's more like on the suture area of the almonds. When you looked at those and symptoms looks like this, sometimes you can see the powdery stuff that's coming out. That's the combination of frass and the nut meat. Other times you can see those circular hole in there. That could be another indicator too. And sometimes you see the powder is kind of loose powder, but most of the time when they tangle with the frass, then also you can see very fine webbings, not like navel orangeworm, but very fine webbings, and you can see in some of that in these pictures too. Okay, so these are some of the adult and larvae that extracted from the same beetle, same nut, and you can see the level of damage, right? So in navel orangeworm, you looked at the navel orangeworm damage, you see 1 or 2 larvae feeding on it. But in the Carpophilus, I've never seen one single larva feeding on it. There is always multiple, 5, 7, 10 larvae. So because of that, pretty much the nut is consumed by the time they find out. So that's what it's going on in most of the cases. Other times, so when you see the beetles and feeding on it, and I suspect that the beetles inside this one, you can see the hole also. So they're making the holes going into and feeding on it. So there might not be larvae yet there, but that seems to me it's more like a adult damage because you don't see much of the webbings yet. You don't see that kind of pulverized and you see in the earlier photo. So again, adult and both larvae can feed on it. So how you differentiate that with other insect? We recently produced a visual guide. I'll show you the barcode. You can get the link. But if you looked at Carpophilus truncatus or the Carpophilus beetle on your left, and then the ant damage on your right. Right. So again, for the ant damage, sometimes you can see that all the nut meat is gone, or sometimes you can see the small area that has scooped the nut meat out, and there is no frass or no little bit webbings present in ant damage cases. On the right, on the bottom, you can see on the ant damage also again clear white powder, just loose powder there. Versus again with the Carpophilus beetle, you see the frass combined and then also some level of webbing. So that's the way to differentiate it. So we produce this visual guide. You can use that barcode and get a PDF copy. We're also working with the UC State or IPM program to put these into the standard format in a white page there with the UC statewide IPM program, and you can access from there too. But we're working on this. But this PDF is already available, and you can look at how you can differentiate Navel versus Carpophilus beetle damage with the other insect like Navel and ant damage. Okay, so if you move on to Navel versus Carpophilus beetle, only I want to say Navel a lot more bigger webbings, big chunk of frass, brown color frass, a lot more nastier than the Carpophilus beetle. If you find that those two nuts that is separately infested by those, right? So on your left, you can see again the palette of the frass of Navel is much bigger, longer, compared to more or less like a powder form for the Carpophilus beetle. Again, I'm just describing this in too much in detail, but I think it's important in order to identify them that way. Sometimes you can see those same nuts, it's infested by both, and as you see in here, you can see the red line covered area is the one that the Carpophilus infested, so a lot more wider, more powdery, versus if you looked at on the yellow line, circle line here, has this frass, brown color frass with the Navel. So that's how I differentiate these two damage. But when you have the same nuts infested by the both, it's very difficult. And most of the time you'll see Navel because it's much more noticeable in many ways. So also the visual guide has this pictorial differences between Navel and Carpophilus beetle, including the egg and also the larval stage, the pupa, as well as the adult, right? So for the egg, this is a kind of older picture that I have here, but I changed it to the kind of bigger, nicer picture. It's kind of a longer oblong type of egg, white color egg, and it's looked like a sort of like close to the rice grain on the cell or on the hull. For Carpophilus beetle versus the Navel eggs are more like a flat, as you see in here. The larva, as you see, the best indicator for the identifying larva is to see those two kind of projection at the end for Carpophilus beetle larva. Versus Navel does not have that, and most of the time in trained eyes you can see Navel versus this one more clearly. Moving on to a little bit on the biology side of things. So when they infest the nuts and what we've seen so far. We've been tracking Carpophilus beetle since last fall in a couple of orchards, basically doing the weekly sampling, collecting the mummy nuts and counting them. We also put some of those mummy nuts in the one small tent cage in the orchard and trying to see when these beetles will emerge and become active, and those kind of things. One difference in terms of their overwintering is navel orangeworm overwinter as in larvae, and then these Carpophilus beetle overwinter as beetles, so the adult. At the hollow split time, as you see, there are some egg laying happen there. So we think that they make a hole on the cell and then lay eggs in there nearby, or sometimes they go inside and then lay eggs inside the nut meat too. We've seen the egg masses, eggs pretty much everywhere. We've seen between hull and cell. We've seen the eggs on the cell itself. We've seen the eggs inside the cell on the nut meat. So it's kind of pretty much randomly we're seeing the eggs on that nut. So there is no specific location for these guys. So they can lay eggs in different places. So from there, at the hollow split time, and then the larva would basically hatch and then start feeding on the nut meat. They go different lives, like a couple of different instar, and those larvae will eventually, we think, it's drop on the ground for the pupation. So the pupation happens on the ground in the soil. And those pupae, again, the adult emerge from the ground. Those adults will fly back to the almond and feeding on it, and probably a couple of cycles goes in that way. We're still trying to figure that out. It's not that easy to figure that thing out. But we suspect that based on the seasonal abundance of the beetles that we're seeing throughout the season, we at least suspect that after the hollow split, there will be at least 1 or 2 generations going even after the hollow split. Another thing that in a lab setting, these beetles will do a lot better. So lab-based trial may not be the best indicator. Even in Australia, they said that they can complete up to 14 generations per year in the lab setting. So we need to find something that will do more like a field type of work in order to find out how many generations they will recycle until the harvest happens, that kind of thing. The other additional thing, so these beetles, they overwinter in the winter time in those mummy nuts, right? So majority of the cases, I would say more than 98% of the beetle that we're seeing is on the ground mummies. So inside the ground mummies, that's where you find the beetles in the winter time. So anytime you can survey and sample in those on those nuts. And as spring begins, so we start seeing the egg and the early stage of larvae around mid-March on those mummies on the ground. And so where they lay eggs, and then again the larvae will start feeding on those mummy nuts on the ground. At least 1 generation happens, but given our temperature, everything, I think probably a couple of generations probably happens on the ground also before they become adult and move into the tree. So those ground mummies are really, really crucial for Carpophilus beetle to survive and build their population. Really, that's a critical resource they have. That's the only resource they have to survive winter through the hollow split time. Tree mummies are more critical for navel orangeworm because you see a lot of infestation on tree mummies, but for the Carpophilus beetle, ground mummies is critical because they like that environment, like with the close to the soil, the humidity near to that, a little bit of grass that helps to build the humidity. So those environments are the one that they survive, they do well compared to the drier conditions. So because of that, the ground mummies are really, really critical for their survival. So what are the other things we know about monitoring this beetle? There are still not the commercially available monitoring tools specific to Carpophilus truncatus. There are some for other Carpophilus genus, but you can get all kinds of Carpophilus on that one. The Australian scientists, our colleagues there, they found the aggregation pheromone from these beetle, and then also added some host-specific volatiles onto this, and so it became an effective attractant. So still it's not commercial, but the Houston Wilson lab obtained those pheromone from Australia. Now we're testing up and down the valley. I put those traps like about a month ago or so, and every week we're catching a lot of these beetles in those smaller traps that we put out there. So this could be one effective tool. Seems to be very seems to be a lot more specific to Carpophilus truncatus as compared to other Carpophilus beetles, so it can be one tool. Again, this is a very early stage, so we'll continue working on this. The other thing which can be done is nut sampling. As I said, if you go orchard right now, you will be able to see the damage. If you go throughout the winter, if you do the mummy sampling, you'll be able to see those beetles on those mummies. So that gives you the indicator of whether there is Carpophilus beetle damage or not. Again, the remnant nuts on the ground during winter is important. Interesting observation, we put some Peterson trap out in that particular orchard and also some egg trap just to see whether they are attracted to that one. So the Peterson trap has this like a ground pistachio bait in it on those wing trap. And so because it's a ground pistachio, the adults are attracted to that and they go and lay eggs there. And those larvae, when they feed on it after the end of the feeding period, they will need to drop in the ground to pupate, right? So they're dropping on those sticky cord, and we're seeing tons of, I mean, you should be able to see the white larva on that sticky thing. So we're seeing a lot of these in there. I don't know whether it could be the effective trap or not, but at least the indicator trap, right? So if you don't have anything else, you still provide the idea about the Carpophilus presence in the area. But again, we're working on a more specific trap that works for Carpophilus truncatus. Timing in terms of when these beetles become active and start laying eggs on a hollow split nut. This is the work done in Australia. So their mid-January is our mid-July, so it's around the hollow split time. So 1% of hollow split time, when they look at those collected hollow split nut, they did not find any damage at that time on those nuts. But if you go to 1 week after and 2 weeks after, that's where the damage is increasing exponentially, even a month from that. So as you go past that season after the hollow split, your chances of getting more damage is higher. In our case, I mean, several orchards that we monitor, we found Carpophilus beetle active as soon as hollow split happens. So 1% hollow split, that's where we're seeing the beetles are already active and they start laying eggs. So I also had the impression that maybe it's a late season stuff, but it's not. They will just active whenever the hollow split happens in the orchard. And here are some of the examples of that and some of the pictures that have taken in some of the collaborative orchards that we work with pest control advisors and growers and those. So you can see the Carpophilus beetle there. When you look at the hollow split timing, you can see when you open those hollow split nuts, and that's where you're seeing the beetles, 3, 4, 5 beetles inside. At the same time, I looked at some of the ground mummies, and they have beetles in there. So that means the ground mummies are producing the beetles, moving up, flying up, and then infesting the nuts. So it's really convenient for them to have the ground mummies right there and then just to find the hollow split nut after that point. Okay, so this is an example of their random egg laying behavior. You can see on the shell there are some eggs. There are some eggs on the nut meat. So as I said, there's pretty much everywhere they can lay eggs in there. Again, more pictures, and as you see between the hull and shell, the green hull, and there are multiple beetles. I found up to 25 beetles in one nut, so it's pretty crazy when you looked at those numbers in there. Okay, so some of the things that we have been doing trying to understand better this insect, because as you know, the basis for IPM is you first need to understand their behavior, because the insect, we need to first understand their biology and behavior. So some of the things that we're kind of trying to understand a little more, we have some lead from the Australian colleagues, so we already know some of this stuff, and we're trying to still continue learning about this insect. So I'll present a couple of few things that we looked at it, about their overwintering habit, about their damage distribution in the orchard, and tree canopy also. So as I mentioned, this is just the pictorial that I definitely wanted to show you to the audience, is that when you have the moldy nuts on the ground, that's the best place for Carpophilus beetle. So as you see in there, that moldy nut, there is a Carpophilus beetle adult, and the other one you can see the hole also there, and then there are 2 beetles in surviving. Even those sprout almonds had beetles also present. These are all from the ground mummies. Also, I also had these orchard had some level of mummies on the ground. They did the winter sanitation, but was not the perfect. And so when you looked at some of the nuts there, you can see the holes, right? So majority of them, sometime when they are on the ground, there will be other Carpophilus or Nitrodilid also infest and feed on it. So it's not like everything you see in the mummy nuts may not be Carpophilus truncatus, but majority of them are based on their infestation and there. So as I said, the Carpophilus, other Carpophilus species would not infest on the tree, on the nuts, but when they're on the ground and the soil, they can go and feed on those as a secondary. So these are some of those example of those holes in there on those mummy nuts. So when you look at, I already mentioned that there is larger number of you can always see multiple number of the larvae, different stages of the larvae and beetles together in the one nut. And so compared to the navel ongium, you see 1 or 2 on an average, right? That's what it shows in here. Another thing that I found also, it might have implication is that when you do the hull split spray, right, if some of that will basically maybe touch some of those insect, the beetles that is just on the nut. But if there are 5 or 6, if the 3 were dead, still there are 3 still alive. So that's also might have implication in terms of how these insects might be, might not be how we're not able to control these very effectively with the insecticide also. Okay, so this is also the different, this is not a varietal trial. This is not the varietal susceptibility differences. It's more of the collection of the different infestation from different orchard with different variety. As you see, these are some of the variety that we've seen the infestation. So it seems to follow the similar trend like navel ongium, where independence variety, non-pearl, soft shell variety are more susceptible compared to the hard shell variety. We had one case where there is independence here, and the next block is the Butte Padre. That's where we compare those also, so that Butte Padre literally did not have anything. Well, there was a very, very few infestation in Butte Padre compared to the independence next to it had a lot more. So it definitely shows the trend that way. I already mentioned that majority of the overwintering population happens, they survive on the ground, not on the tree. So that's the contrast with the navel ongium. So because of it has implication in terms of when you do the winter sanitation. It's a ground focused winter sanitation, really, really critically important for these guys compared to the navel ongium. Navel ongium, you still have larvae can survive on the ground mummies, but with all the other things, rain and other things can kill certain percent of larvae in there. In this case, they promote Carpophilus beetle on those environments. So that's important to know. We also looked at both mummies as well as the fresh nuts that we looked at in different layers in the tree, and then see where we found the majority of the infestation. In Australia also they saw the kind of more or less similar trend. Naturally, as you now know, that overwintering happens on the ground, so you see a lot more activity and damage on the lower portion of the canopy compared to the top of the canopy, which is reverse in navel ongium, right? So you expect more damage on the top of the tree versus that. Within the orchard, all of these we're still working, right? So these are a couple of orchards that we are doing sample for 5 different orchards. We'll continue working on this in order to have the solid final results. But we're also seeing the more of the age effect too, where the orchard border had more damage compared to the interior of the orchard. But again, these are still the work in progress type of results. So just take it that way. So in terms of the managing Carpophilus beetle, I already mentioned several times that mummy sanitation is the key. Some of you might have attended that webinar that we put together with the Australian colleagues. They are also, the bottom line is they call the orchard hygiene, right? So the winter sanitation is critical to manage these pests, because they don't have any other place where they can overwinter and survive. So that's the only source. So the winter synthesis, especially the ground mummies, are critical for Carpophilus beetle. Also, the effective mowing. So when you have the beetles, when you do the flail mowing, to make sure that those nuts are split, right? So it's kind of like, and to become a stage where the beetle would not survive more. So we're planning to do some work in this winter and maybe next winter. Hopefully there was a funding that I submitted. Hopefully there will be some funding also to look at how we can see the effective winter synthesis and what kind of equipment we can use, how many times, maybe 1 pass, 2 pass, and those kind of things to see the effective mummy synthesis. Because these beetles are different than Navel orangeworm. So we need to do a really good job in terms of sanitizing the orchard and make sure do the 1 pass, 2 pass if possible, and make sure that you have those nuts that is split. Insecticide, and because as I said, the disking doesn't help because they are soil-loving insect also, so they survive really well within even 1 feet, 2 feet deep on the ground. So based on some of the work done in Australia. Okay, so insecticide trial we did one this year because it's, of course, we wanted to see what kind of insecticide, what timing we'll be able to use it. So we did collaborate with some of the private consultant on this one, and then we did the sprayer. We used the kind of research type of sprayer with the 50 gallons capacity. We did apply the materials at night, and so this is a kind of design where we had 4 blocks and 10 different treatments that we put in 1 block and replicated 4 times as a block. And all of the details are here. I'm not going to talk too much about that. But so essentially we use the insecticide that commonly we use for Navel orangeworm, commonly we use for stink bug. So anything that is legally you can use in almonds. That's what I went after. 10 different insecticide. And here is the results. This orchard had really high Carpophilus beetle, okay? So you can see those numbers there. These are the sample we collected about 7-10 days before the harvest. We collected from the tree because we wanted to make sure that we're collecting the nuts from the lower portion of the tree so that the coverage may not be the issue. We still have the harvest data also. I'm not going to show it here, but we've seen the more or less similar trend. But essentially, none of these insecticides work in a statistically significantly separated. None of those treatments separated. As you see, there is a lot of variation, and you expect that in Navel orangeworm, and more so on the Carpophilus beetle. But you can see untreated control had 22% damage. Other treatment were anywhere from 14, 15 to 20, 22% damage. As I said, as a person working as a scientist working on this area, I would not see that one insecticide does better than others because it did not, right? So you can see that there is a little bit differences, but if it's not statistically different, that's not real difference. So, I mean, we're kind of expecting that the insecticide might not do a pretty good job. As I mentioned, some of the reason is that the coverage is critically important. When you looked at those beetles in the hull split time, you see between hull and cell, even you don't notice them until you start splitting them. And even though you might kill 1 or 2 in there, but there was 4 inside, so that might not toss them. And so all of that reason, and their population can be pretty high at that time. So, and coverage is always issue, right? Even with the Navel orangeworm. So I think it's multiple reason is playing into role. So I think we still continue doing this work, and potentially we'll use these insecticides and see whether they will actually kill the beetles or not if we use in a laboratory setting or spray on top of the beetle. They might kill some, but so I wanted to kind of explore a little bit more on that, and we'll continue doing the insecticide trial, trying some of the other things, but it doesn't seem like we're getting the good control with the insecticide. And these are applied at 1% hull split time and 14 days after. So it was Navel orangeworm timing. The other thing could be that if there is a third insecticide applied later, maybe 10 days after or so, that might have been a little bit maybe improve the efficacy. So those are the things that we need to think about too. But also how many times you will be able to apply. So in summary, Carpophilus beetle, it's a newly confirmed pest, and sometimes it's so. One of the additional stories that the Australian, they have done some work recently and published a paper, and they said that they have finding the Carpophilus truncatus from the museum samples from different places. They put the traps, even the area where there was no nut growing region. Now they are finding some Carpophilus truncatus in there too. So their version is that this is really not the invasive pest. It's more of the pest is already there, but we have a lot of host crop now in the nut crops. They specialize on nut crops and causing pretty much damage. That's still debatable, but I mean, given the level of damage we're seeing in California, definitely it's gained the status of the invasive pest because it's a widespread and causing problem. Monitoring tools, hopefully it will commercially available, some of those tools in next year or so, but we'll continue working on that. Effective sanitation is the way to go, and I even can't believe that we can control. I don't think that we can control Carpophilus beetle without doing winter mummy sanitation, based on the orchard that I have visited so far. Insecticide efficacy is limited. We're still working on this, but it's just not very reliable. Another thing that we probably will be exploring would be maybe if there is something that we can apply on the ground when they're overwintering. In the wintertime, maybe early spring or early summertime. Some of the microbial, maybe like insect pathogenic fungi or nematode, or some of those things that you can openly apply on the ground and then maybe have some efficacy. And some of the work is done in Australia, just kind of limited work on Beauveria bassiana. So some of those tools can be something that we want to explore, just kind of reducing the population when they're overwintering. Okay, with that, I would like to thank everyone here, and plus the funding agencies. Almond Board and Pistachio Board has started funding right away, and so we're working on that. Hopefully we'll get other additional funding also, and we'll keep working on this. And again, if you want that visual guide, this is a direct link for that PDF. You can get that from this link, and with that, I have 5 minutes to go.
Is there any work done on biological control with the parasite from the original places, etc.?
Parasitoid, it's very difficult. Probably some of those, like a wasp and other things will be probably has less hope, I have, compared to something that, as I mentioned, insect pathogenic fungi or nematode or some of those biological based products you can apply on the ground. So in that case, wintertime we have a moisture in the environment, humidity is not a big deal, right? So as long as we will be able to apply around that time, hopefully that would be the something that we could apply, and these are the biological based products, so how much you can apply. As long as they're effective, you'll be able to do that without any concern for other things. Mel?
Did you notice any difference in infestation rate with orchard floor conditions? If you had a good, clean orchard floor, did you have the same level of infestation versus one that was messy? Lots of weeds, lots of detritus.
Definitely the messy one had a lot more damage. Yeah, and again, as I said, and also when just kind of the ground microclimate environment and a little bit humid environment is where they grow, they do the best. And so if you have that kind of environment, you likely have more damage.
Did you notice any difference in infestation timing early at hull split, kernel soft, high moisture, versus after the kernels dry out?
So we had that initial hull split time. That's where we had one kind of one flight potentially. I mean, there is always overlapping flight with these things, but there is an increased number of the beetle activity in the earlier part of the season, and around mid-August, there is another flux that we've seen in the beetles in there too. Again, these things are a lot more overlapping compared to the navel orangeworm, and they are in the soil habitat, so their emergence is just varies by a lot of factors, and some of these beetles may not even emerge in 1 year. In the soil environment is sometimes like that. So because of that, we see a lot of overlap. But yeah, and when you see right now, if you go in the orchard, you can find both larvae and beetles, and still inside those nuts too. So they, as long as they have a temperature right, they're just potentially recycling several times. Okay, thanks so much.